All right, hello chemistry students. You'll have to forgive me, I'm a little under the weather, so if I'm a little hoarse coming through, I apologize. Today we're going to talk about predicting reaction products, what we've been working on in class for a while, but I've received a lot of questions about it, and I just want to clarify everything that we covered as notes in class so that you guys are prepared. So for predicting reaction products, I've identified some key steps and I've tried to summarize them in as simple language as possible to see what we need to do. The first step is to identify the reaction type. Now I've given you plenty of practice on this in terms of figuring out what a reaction type is, what's a single replacement reaction, what's a double replacement reaction, and you should be able to figure that out just based on the chemicals that are present in the reactants for the reaction. Again, there's some practice on that in some other videos that I've been posting online, so you should be able to get that there. Next, we want to predict what the chemical combinations are of the products. So basically, the way that I've summarized it is, we can figure out what the chemical names are. We can figure out who is going to pair with who, what positive ion is going to pair with what negative ion. However, that doesn't in and of itself predict what the chemical formula of the product is going to be yet. That's why there's an entire separate step, step 3, which is predict what the chemical formulas of the products will be. So we predict the chemical combinations, we predict the chemical formulas, and the way we're going to predict chemical formulas is by using the drop and swap method to figure out what a balanced ionic compound of those ions is. The final step, sort of, is to balance the equation. So once we figured out what the chemical formulas are of the products, then we can balance. If we don't have the proper chemical formulas here in step 3, balancing the equation in step 4 will not go correctly. And you'll make invalid assumptions about what the balanced equation will look like, and that will be a problem. And then step 5, if you want to, it's a little bit advanced and there is some issue with it in terms of how accurate it is to be able to do this without having seen the reaction or without having done it experimentally, but we're going to try to do it in terms of predicting the states of matter. This we'll cover in another video. We're not going to cover this today in terms of using the solubility pyramid to determine what is an aqueous solution and what is a insoluble precipitate. Being able to predict what things are gases and what things are solids is mostly pretty intuitive depending on what you're doing. So we're going to try to follow this 5-step process, and I've got some example problems over here that we'll use in order to figure out what the reaction products are. So on the first one, we look at our reactants. We have magnesium metal, and it's reacting with calcium chloride. Now, because I have an individual element here reacting with an ionic compound, we know that this is going to be a single replacement reaction. Going to be single replacement. And what we're going to predict is going to happen is that the metal, this magnesium metal, is going to come over here and it's going to kick out calcium. Metals are going to replace metals because they're both positive ions. So what type of single replacement reaction this is going to be is this is going to be a cation replacement. So we'll say cation. So we know that magnesium is going to come and replace calcium. So we then know that our products will be, in predicting the combination of what the products will be, magnesium will combine with chlorine, and then calcium will be by itself. Magnesium kicks out calcium. Now, we then need to identify what the chemical formula of this magnesium chloride is. The way that we do that is by saying that magnesium is going to take a 2+ charge as an ion based on its placement in the periodic table, and the chloride ion is going to take a -1. So using the drop and swap method, magnesium chloride would have 2 chlorines and 1 magnesium. So our formula for our products are MgCl2 and then calcium metal. So again, it's worth noting what we did there. we knew based on the type of reaction that magnesium would replace calcium. And we knew that we would make magnesium chloride. But until we did this right here, we did not know that magnesium chloride had the formula MgCl2. We could have just as easily assumed that it had the formula MgCl or MgCl3 or Mg2Cl. We would not have known until we did the drop and swap method in order to figure out what this chemical formula was. And if we look at this chemical formula to do step 4, in balancing the equation, we can see that we have one magnesium, one calcium, 2 chlorines, and that this equation is already balanced the way that it's written. If we had a different chemical formula for magnesium chloride, that would not balance that way. You would end up with different numbers and it would screw everything up. So it's important that we have the proper chemical formula. This is the only possible chemical formula for magnesium chloride because it's the only ionic compound of magnesium and chlorine that's chemically neutral and where everyone has their octet satisfied. So let's go on and try again. I don't want to be too long-winded in this so that we have time to go through all of these and you have time to watch at least one more video. Let's take a look at this one. So again, we have the same pattern of a single replacement reaction. We have a chemical by itself mixing with an ionic compound. So this is going to be another single replacement. But in this case, the element that's by itself is a non-metal. So unlike this equation where the metal is replacing a metal, in this case, the non-metal is going to replace a non-metal. So based on this, we know that this is going to be an anion replacement reaction. We then know that since chlorine's coming and kicking out bromine, our products will be magnesium combined with chlorine and then bromine by itself. So taking a look at this, we need to predict what the chemical formula of this is going to be. So again, magnesium has a 2+ charge, chlorine has a 1-. So our formula would be MgCl2. Trickily enough, when we take bromine by itself, bromine is one of those diatomic atoms, one of those elements that always appear paired with itself, like oxygen gas always appears as O2, chlorine gas always appears as Cl2. So we would need to write this as Br2. If we then look at this chemical formula, we can see that it is balanced. We have 2 chlorines and 2 chlorines, 1 magnesium, 2 bromines, 2 bromines. That's an overall balanced equation. Again, it was critical to predict who paired with who before figuring out what our chemical formulas of our products would be.